Okay, in this video, let's discuss the question add modulo 10. Let's read the question first. You are given an array of n integers, a1, a2, and so on up to an. You can apply the following operation on any number, any arbitrary number of times. Okay, select any index I which is between 1 to n and replace the value of element I with its value ai plus ai mod 10. Okay, where ai mod 10 is the remainder of the integer dividing ei by 10, which means the last digit of the number. For a single index value I, the operation can be applied multiple times. If the operation is applied repeatedly to the same index, and the current value is taken into the account each time. Okay, for example, if ai is 47, ai will become 47 plus 7, which is 54. Okay, if it's 54, 54 plus 4 is 58. Okay, check if possible to make all the array elements equal by applying multiple operations. Okay. Okay, we are given an example here. Let's consider 6 and 11, A1 and A2. Then for the first operation, we'll apply the operation on number 6, which is 6 plus 6 modulo 10 is 6, which is 12. And on the second element, we apply the second operation, which is 11 plus 1, because 11 mod 10 is 1. 11 plus 1 is 12. Both the array elements are equal. So we can simply print yes in that case, or else no. See, 6, 11, the answer is yes. Okay, let's discuss how to solve this question with the help of some examples. Okay, now quickly observe that what are the changes are going to happen when we add modulo 10s to each of the digit from 0 to 9. Okay, for 0, if you add 0 plus 0 mod 10, it won't be any change, or the digit gets changed. So it's 0. If it's 1, then we'll add 1 plus 1 modulo 10, which is 2, and we'll add 2 plus 2 modulo 10, which is, and we'll add 4 plus 4 modulo 10, which is 8, and we add 8 plus 8 modulo 10, which is 16, but we add 16 plus 16 modulo 10, which is 22. You carefully observe the units place, which is 2, is going to be repeated again and again. An average difference or with a difference of 20. If you carefully check, the difference between them is 20. Okay. Again, if you add 22 plus 22 modulo 10, which is 24, because 22 modulo 10 is 2, 22 modulo 10 will be equals to 2. Okay, in this way, 22 modulo 10 is 2. And the number 4 is again repeated. I mean, we are talking about the units plus digits right now. And if you start with 2, it will change to 4, and it will change to 8, change to 16, and it change to 22, and up to so on. Okay. But if you start with 3, it will be changed to 6, and 6 will be changed to 6 plus 6, 12, right? Because 6 modulo 10 is also 6, and 12 plus 2, I mean 12 plus 2 is 14. Why? Because 12 modulo 10 is 2. 14 plus 4, which is 18, right? And 18 plus 8, which is 26. Okay. And again, if you carefully observe, whenever the last digits are same, or the units places are same in these two digits, the difference between them is 20, right? And we can clearly say that the number 12 is the main part or the major role here, and let's discuss that why later, or let's discuss within a minute. And for 4 we have already seen how it changes, and similar for 5 it will be changed at most once, but why? Let's check. 5 plus 5 modulo 10 is 10, right? And 10 plus 10 modulo 10 will always be 10, and there will be no change as the reminder, or the last digit of the number is 0. So if you add 0 to any number, it won't get changed, right? So if the units place of any number is 6, we have already discussed how it changes. If it's 6, it will first go to 12, and first it will go to 14, and then it will go to 18, and then it will go to 26. In that, if the number is 7, 7 plus 7 modulo 10, which is 14, and 14 plus 14 modulo 10, which is 18, and 18 plus 18 modulo 10, which is 26, 26 plus 26 modulo 10, which is 32, and 32 plus 32 modulo 10 is 34, right? So whenever the units place is repeated and the difference between them is 20, right? And if you check the number 8, it is already discussed above, but now again discuss that. If the units place of any number is 8, then it will change in this way, like 8 plus 8 modulo 10, which is 16, and 16 plus 16 modulo 10, which is 22, and 22 plus 22 modulo 10, which is 24, 24 plus 24 modulo 10, which is 28, and 28 plus 28 modulo 10, which is 36. So in this way the numbers are changing, and whenever the units place are same for any two numbers, if you take the difference between them, which is 20, and the number of operations we are doing to get the difference 20, or to get the units same, is like 1, 2, 3, 4 operations, right? First operation, second operation, third operation, and fourth operation. Like for every 4 operations, the difference between the numbers are going to be increased by 20, right? If the units place is 9, then it will be start with 18. Why? Because 9 plus 9 modulo 10 is 18. And 18 will again transformed into 26. 26 will again be 32. 32 will again be 34. 34 and again will be 34 plus 34 modulo 10, which is 38. Then if you take the difference between 38 and 18, it's 20. Okay. Okay, in this way the numbers are going to be changed. I mean the units place of numbers are going to be changed. If you carefully observe, in order to make all the array elements equal, we need to say that all the units place of those numbers should be equal. Then only the array elements can be equal, right? Okay, now let's discuss the first case, which is if we are given the number which is having unit place as 5, then how can we make all the elements equal to one number? Let's check that case. Okay, let's assume, or first we have to know the digits which are divisible by 5, and then we'll make one operation to that digit. Okay. Let's say we are given an array of elements which is 10, 15, and 5, and it's again, let's say 10 again. Then if you do this, or if you do the operation on this number, it still remains the same. Whereas if you do any operation on this number, it will be 20, right? If you do any operation on this number, it's 10, and it will be 10. So in this case, if you see, the whole array is not equal, right? So we can say that if the given array is of this, we can simply say no. Okay, why? Because we are getting 20, which we are not needed. And you can simply check whether the whole array is equal or not by just picking the minimum element of this array, which is 10, and picking the maximum element of the array, which is 20 in this case. Sorry, which is 20. If these two elements are not equal, then we can say that the array is not equal. Like the array elements are not equal. Okay. Or else we can say that the array elements are equal. But why are we doing operations on this? So if you consider the numbers which are divisible by 5, we can do at most one operation to that number, right? So let's assume that all the given numbers are 5, 5, 5, 5. Okay. Then if you do one operation to every number, the the final number they'll be changed will be 10, right? So no, there's not much difference if you make this operation. Okay. But when the given numbers are like this, then if you do the operation, then it can clearly stating, or then you can clearly see that these elements are not equal, right? So whenever there is a 5, we can do the operation once to the elements which are divisible by 5, okay? Or else we are having these cases. If the number is not divisible by 5, means the last digit of the number can be 1 to 9 except 5, right? The last digit of the number, let's say last digit is D, it is somewhere around 1 to 9, but not divisible, but equals to 5. Okay. So let's talk about that case. If the numbers are odd, let's say 1, 3, 7, 9, let's make them into even number. Okay. Or let's make the last digit of these numbers as 2. Okay. Why? Because if you clearly observe, whenever there's a starting digit 2, then it can transform into 4, then it can transform into 8, then it can transform into 6, then it again can be transformed into 2. And this whole process, the value of 20 is being added to the number in this whole process, right? So we will change every number a digit into 2. So at last we can easily check whether the numbers difference is 20 or not. If the numbers difference is 20, then we can say that by doing some x operations, which can be divisible by 20, then by doing those number of operations, we can equate those two numbers. Let's say, for example, if the numbers given are 22 and 42, hmm, after making the unit digits of them equal, which is 2, the difference between these two numbers is 20, right? And the difference between them is divided by 20. So you can do one operation of this entire type and make the 20 into 42 easily. So that's the reason we are making the units digit as 2. Okay, did you understand? Like the start of this cycle is basically from 2. Why? Because if you need the 2 again, we can add 20 to that number. Okay, let's say if the number is given as 22 and 12, the difference is like 10, then the value 10 which is not divisible by 20, so we can say that this is not possible. Okay. In this way we can say that whether, whether we can make all the elements in the array equal or not. In that way we can say whether the all elements are equal or not in the array. Okay, now let's discuss the code. Okay, now let's discuss the code part. First line we are taking the input of the size of the array, and in the second line we are declaring that array, and this boolean variable is used to know whether the elements in the array are divisible by 5 or not. If you observe the pattern, when we add the 5 repeatedly, this can be done at most once, as the mod 10 will be reduced to 0, which we have discussed before, right? So we are taking the numbers as an input and checking whether one of the numbers or any of the number is divisible by 5. If yes, divisible, then we will update the number which is next of the nums of I, and the next method is written here, which returns the value, or which returns the operation which is being performed or should be performed, which is mentioned in that question, which is number plus number mod 10. Okay. Okay, then if the number is, let's say, 10, then 10 modulo 5 is 0. So we can make the number 10 into next of the number, which is will send the argument which is 10 to the next method, and it will return 10 plus 10 modulo 10, which is 0, and 0 plus 10, which is 10, and it will return the value of 10, and the nums of I will be updated to 10 even it's 10. Okay, then we'll state that there is a number or there is an element which is divisible by 5 in the array. If there is an element which is divisible by 5 in that array, then we have to check whether we have made all the elements are equal in that array or not. Okay. If arrays dot stream of nums dot min dot get ascent, in this line states that the minimum element in the array, and this states the maximum element in that array, right? As I'm little lazy, I have written this using stream, so sorry for that. Okay, and if both the elements are equal, then we can say that the whole array elements are equal. Else, we can simply say that the array's elements cannot be equal, or we can say that if we do any number of operations, the elements in the array cannot be equal. Okay, or else there is a case which is having, or which doesn't contain the elements of multiples of 5. Okay, there's no element which is multiple of 5, then in that case the elements are in the type of 1, 2, 3, 4, and 6, except 0 and 5, all other elements can exist in the array, which means now boolean flag 2 is false, boolean flag 12 is false. Let's discuss this. Okay, if already we have discussed that we will change every element's unit place into 2, which we have discussed before. Why? Because the 2 is the main entry point of the loop. Like if you are having the units place as 2, and if you want to make any other element which is having the same units place but the tens place of those two numbers which are not equal, then if you check whether the difference between those two elements is a multiple of 20, then we can make them equal, or else we cannot make them equal. Okay. Okay, value equals to next of value. We have discussed the method value. So we'll change that number until and unless the number is having the units place as 2. Okay, if that number is divisible by 2, or I mean, sorry, if that number is giving a remainder of 2 when we divide it with 20, then there are two cases, which is either the number can be 2, comma 22, comma 42, and so on, or else the number can be, okay, the number can be 12, 32, and 52, sorry, and this way and so on. Why? Because in this loop we have changed every digit's unit place as 2, right? Every element's unit place as 2. So at this point of time, the value will have the units place as 2, and that unit place, when it gives only the remainder 2 when it's divided by 20, then the number is in this type 2, 22, 42, and so on, or else the number is in this type 12, 32, 52, and so on. Okay, then if we can say that if the array is having only these type of elements, then we can make the array equal. Why? Because if you consider the array elements in this way, which is 2, 12, and so on, and so on, and if you consider these two elements cannot be equal. Why? Because if you perform any operation, we can add 2, 4, and then 8, and then 6. So after performing these operations, we are adding plus 20 to that number, not plus 10, right? So the difference between these two is 10. So if any two numbers which is giving a remainder of 12 and 2 in the same array, then the answer will always be no. Will always be no. Why? Because we have discussed that case here. If the elements which are giving a modulo 2 and 12 in the array, then we cannot make them equal, as the difference between them will be 10 or the multiples of 10, right? We cannot get the multiples of 10, or we cannot add the multiple of 10 to a number with some particular operation. So it's impossible. So at last we are checking that if both type of elements exist in the array, then the answer is no, or else the answer is yes, right? Okay, now let's check the result after the submission. Yeah, it shows accepted. Okay, thanks